Hello, everybody. I'm going to go through the solution of question 74 of the calculus section of the course Maths1151 at the University of New South Wales. Now, the question is, if the limit of a function f when x goes to a is capital A, and limit x goes to a, gx is equal to b, we would like to prove that the addition of this function and then the taking a limit is equivalent to the taking a limit of individual functions. And we would like to prove this by using an epsilon-delta limit definition. So these two are the given equations. So we will move from here to here. What is the epsilon-delta definition for this equality? This is just by the definition that for each epsilon, as I mentioned before, this epsilon is something like between 0 and 1. This is what, even though we just say that it is a positive, but we think that epsilon is a small number. And there exists a delta A such that, bigger than 0, such that for all x, I think I need to say such that here. There needs to be a such that here. Right? Such that for all x in R, this inequality implies this inequality. So this is basically the limiting, you're looking at the open interval of x. Now you're looking at the open interval of f of x. So here, this and this one gives you an open set subset of R2, but open set basically, like a triangle region from here to here. If you looked at the epsilon-delta definition of your lecture, you will see how this graphic works. So, and for limit x goes to a, gx is equal to b is a given as well. We use the epsilon-delta definition, and we will have, in the same way, we have epsilon bigger than 0. There exists a delta b such that, again, I need to have a such that here. For all x in a real number, this inequality satisfies this inequality. So we would like to find out the addition of these two functions when limit goes to the x goes to the a. So we need to use, this is given and this is given. So these two given inequality should imply the summation of the inequalities of this and this. So let's start from there. So these are the given to us, and we can add both sides. So we have 0 here, we have 2 here, and we have delta A plus delta B here. When I divide everything by 2, we will have 0 smaller than x minus a smaller than delta A plus delta B over 2. So this is what I want, but this is the delta, right? Because we want to delta for fx plus fb for fx and gx. Right. So there exists a delta because delta A and delta B exist. Then this definition of delta exists. Now consider fx plus gx minus a plus b. We want to prove that this is smaller than some epsilon. By using this inequality for the triangular inequality, we can divide this is this plus this side. We have fx minus a, gx minus b. This is smaller than epsilon. This is smaller than epsilon. Or these epsilons could be different. You can emphasize that as well. It's not need to be the same because for all. But since we are using a for all, I can use exactly the same epsilon. It is not illogical to use the same epsilon, or it is not illogical to use different epsilons for each of these p's. Doesn't matter at all. Either you will say epsilon plus epsilon prime, some other epsilon, or you would say epsilon 2 epsilon is something epsilon, because when epsilon round through everything, you any number between 0 and 1, epsilon prime will be the run through the any number between 0 and 1. That wouldn't be matter at all. So this proves everything, because all we wanted to say that for each epsilon, when epsilon runs through the 0 to 1, then epsilon prime runs through the all 0, 1. Then there exists a delta. We've shown it. There exists a delta because we call the delta as a halfway through of delta A and delta B. And this inequality is satisfied. And this is exactly the definition in the backwards for the limit. So this wording means that limit x goes to the a, fx plus gx is equal to a plus b. That's all we need to do for this question. Thank you very much. I hope this is helpful for you.